This is the luckiest maths teacher in the world. Thank you so much for tuning into this video on logarithms or logs. You've probably noticed on your calculator the log button and wondered what it does. We're going to go through what that button does and what logarithms actually are. So they're actually a tool for solving a certain type of equation. So we're familiar with equations. We've looked at equations like this, 2x plus 1 equals 7. That's a very simple linear equation. We've also looked at quadratic equations like x squared minus 7x plus 12 equals 0. So in both cases, if we want to solve the equation, we want to find a value that we can substitute for x in order to make the statement true. Now the thing is, in each of these equations, we already know the powers. In this first one, the power is 1, because x to the power 1 and x are the same thing. In the second one, we've got power 2 and a power 1. But what we're going to look at today, what logarithms are actually used for, are exponential equations. So exponential refers to the word exponent, which you've come across before. Exponent is another name for index or power. So an exponential equation is one in which the unknown pronumeral, in this case it's been x, is part of the power. So if I have something like 2 to the power of x equals 32, that's an exponential equation because the thing we're trying to find is part of the power, which wasn't the case in these equations. So how do we actually solve something like this? Well, what would be really cool is if we could use the processes for the linear equations, because they're really easy but also really logical. In a linear equation, what we do is undo everything that's been done to x in order to get x by itself. So we want to be able to do that here. We want to undo what's been done to x to get it by itself. But how do we undo raising 2 to the power of something? Well, that's exactly what logs are. What we can do here is use a log to solve. So the solution to this equation is x equals log. So that's what we're talking about, logarithms. It has a base and a power. So log 2 of 32 is saying exactly the same as this equation. The value of log 2 of 32 is saying, to what power do I raise 2 to get 32? That's what log 2 of 32 means. What power do you raise 2 to in order to get 32? So for this one, we could just keep going up by powers of 2. So we know 2 to the power of 1 is 2, then 4, 8, 16, and 32. If I times 2 by itself 5 times, I get 32. So the answer to this equation here is 5, because you raise 2 to the power of 5 to get 32. If I substitute here x for 5, I get a true statement. I get 2 to the power of 5 equals 32, which is a true statement. So writing the log like this here, it didn't really help that much because it's saying the same thing as this equation. But I can actually put this on my calculator. So now I have a way where I can solve exponential equations just using the calculator. So that's what logs allow us to do. So the rule for logs is if I have a to the power of x equals b and I'm interested in finding x is the thing I want to know, I can get x by itself. I can undo what's been done to x by using logs. So if a to the power of x is equal to b, then that means that x is equal to log base a of b. Log base a of b, the answer to that is whatever power you must raise a to in order to get b. So that's what we use logs for. So let's look at a few more examples. Please pause and copy this down if you need. So let's say I had something like log 6 of 36. So I'm saying, what power do I raise 6 to get 36? And of course, that's 2. 6 to the power of 2 is 36. So this is the same as solving the equation 6 to the power of x equals 36. So each log, if you like, with the base and the power, has an associated exponential equation. Let's say I had log 4 of 4096. So this is saying, to what power do I raise 4 to get 4096? And so again, I could just keep multiplying by 4 until I get 4096, or I could just put this on my calculator, and the answer I get is 6, because 4 to the power of 6 equals 4096. Now, some calculators do not allow you to put in your own base. Some of them only have a log button and nowhere to put in the number down here. So usually the calculator assumes that it's base 10. So if your calculator doesn't allow you to put in, say, base 4, how are you going to use it to evaluate something like this? Well, you actually need the change of base formula for that. We're not going to go into the change of base formula too much. I just want you to know that if you want to put log base a of b in your calculator and it doesn't let you choose the base, in this case a, you can use a base 10 logarithm. You just write log 10 of b over log 10 of a. So the black Casio calculators unfortunately do not allow you to input the base, so we need to use this in order to solve logs. So if I wanted to solve the equation, let's say 7 to the power of x is 2401, in my calculator I want to put log base 7 of 2401, but my calculator, the black Casio, doesn't allow me to do that. It only allows me to put in log base 10. So in my calculator, I'm going to put log 2401 power on top over log 7, and the answer I get is 4, because 7 to the power of 4 is 2401. Now logs can give you a negative answer as well. So I can, if I put in this log 3 of a third, it's saying, to what power do I raise 3 to get a third? So hopefully you know by index laws the answer to that is -1, because 3 to the power of -1 is equal to a third. So again, that's the link between the exponential equation and the logarithm. If I have something like log 2 of 1 over 4096, I'm saying, to what power do I raise 2 to get 1 over 4096? The answer to that is -12, because 2 to the power of -12 is 1 over 4096. So again, if I wanted to put that in my calculator, and I'm not allowed to put in base 2 in my calculator, I would just write log 1 over 4096 divided by log 2, and my calculator gives me the right answer there. So please also note that logs won't always give you an integer as they have in all the examples I've shown you so far. So if I wanted to put in log base 2, let's say of 5, that's not going to give me a whole number. There is no whole number you can raise 2 to get the number 5. To do this off the top of our head would be really hard. Human brains just couldn't do it. We can estimate the answer. We know 2 to the power of 2 is 4, 2 to the power of 3 is 8. So the answer should be somewhere between 2 and 3. But it's hard to get the exact answer without using a calculator. So that's one thing that makes logs really, really useful. So to do this, if my calculator doesn't allow me to put in log base 2, I just put in log 5. So my calculator assumes if I put in log, it's base 10 over log 2. And the answer I get is about 2.32. So you have to raise 2 to the power of 2.32 to get 5. We wouldn't have been able to do that off the top of our heads. So please pause and copy this down now. I'm just going to go through some equations that are a little more challenging. So let's look at this equation here. So this is an exponential equation because the thing I want to find, x, is part of the power. But what makes this equation a little different is I have a few more operations. I also have a multiplication and a subtraction. So similar to linear equations, what we're going to do is we're going to undo everything in the opposite order to BODMAS. The only thing that makes this different from a linear equation is that the last thing we do to both sides is take the log to help us with the exponent part. So if this was a normal linear equation, we're just going to add 5 to both sides. So that leaves us with 3 times 4 to the power of x equals 187 plus 5, which is 192. Now remember, because of order of operations, 3 times 4x means you raise 4 to the power first, then you times by 3. So the next thing I undo is timesing by 3, and I do that by dividing by 3. So I end up with 4 to the power of x is 192 divide 3, and if I want to know what x is, I can take the log of both sides. I can use the rule that was on the previous slide. So x would be log base 4 to the 64. Calculator only allows log in base 10. You can write it on your calculator as log 64 over log 4. And you should get the answer 3. All right, let's look at another similar equation to this. So let's look at this equation here. So again, exponential equation, because the thing I want to find is part of the power. So I undo things in the opposite order to BODMAS, so I'm going to start by dividing each side by 5. So now I'm left with 6 to the power of something is 1,296. So now I need to take the log of both sides using the rule that we've gone through in this video. So taking the log of both sides, I'm left with this thing in the power is equal to log base 6 of 1,296. So again, you can put that in your calculator easily. If your calculator doesn't allow log base 6, you can just write log base 10 of 1296 over log base 10 of 6, and you should get the answer 4, because 6 to the power of 4 is 1296. So we have x minus 1 is equal to 4, just add 1 to both sides, and x is 5. And we can easily check our solution by substituting x is 5 into this equation here. So that's what logs are good for. They are good for solving exponential equations. Apart from that, we can solve those equations as we would a linear equation. We just need to use logs when we get to the step where we need to undo raising a number to the power of x, or to the power of some expression with an x in it. Alright, thank you so much for watching. This has been the luckiest maths teacher in the world. Have a great day.